Alright, you know it's me again. Looking at day 2 with writing equations, guys. Day 2 with writing equations. So let's review slope-intercept form. Again, the reason we call it slope-intercept form is because we have the slope and we have the y-intercept. Alright, so m is the slope and b is the y-intercept. So this is what we call slope-intercept form. Y equals mx plus b. Again, m right here, the number in front of the x is your slope. The slope is a number. It does not include your variable. So again, the slope, m, is the number in front of your x. And then b right here is your y-intercept. Again, your y-intercept is going to be a point, and your point is going to be always, always, always 0 for your x value. And then your y value of your y-intercept is going to be whatever b is right there. So looking at example number 1, it says write the equation of a line with a slope of 3 and a y-intercept of -6. So again, a y-intercept of -6, we know we have a point at 0, -6. We have the slope m. Again, slope is denoted as the variable m of 3. So all we're doing is we're going to plug this in place in my slope-intercept form. So we're going to write our slope-intercept form, y equals mx plus b. We're plugging in 3 for m. We're plugging in -6 for b. So we've got y equals m, but m in this case is 3, x plus -6. Okay, now I wouldn't write it like this. I would go one step further and say y equals 3x minus 6. That's how we see it written. Okay, but this is not incorrect. The other thing we learned is point-slope form. Point-slope form is the equation y minus y1 is equal to m times x minus x1. And again, m is still your slope, you guessed it, and x1, y1 is a given point. So we would use this if we had the slope and a point. This point is not your y-intercept. So we can't use slope-intercept form because we don't have our y-intercept. We have it just at a given point. So in example number 2, we have the point 4, -3. Well, that's not your y-intercept, guys. So you can't plug it into this equation because that's not b. That's just a given point. So we have to use our point-slope form. We used a given point and the slope. We don't have the intercept. So there's your big difference. Alright, so again, first thing I want to do is I want to write my equation. Y minus y1 is equal to m times x minus x1. And let's look at our example. What do we have? We have the slope of 2, so we know that m is equal to 2. We have a point at 4, -3. This again is your x1 value, and -3 is going to be your y1 value. So guess what? Let's plug and let's chug. Alright? Don't tell your parents I said that. Alright, so y minus y1, again, y1 is a -3. So y minus -3 is equal to m, but again, we know what m is. M is 2. X minus x1, which we have x1 of +4. So let's fix this right here. We got y minus -3. That's going to change, two negatives right there, to make it y plus 3 is equal to 2 times x minus 4. Okay, so there is your point-slope form. But now, to graph this, guys, we need the slope-intercept form. We need y by itself to graph it. So let's go ahead and convert it to slope-intercept form. Again, the way I do that, which we learned yesterday, is to distribute my 2 to both terms inside that parentheses. So I've got y plus 3 is equal to 2 times x, which is 2x, and then 2 times a -4, which is -8. We got one more step. I need the y by itself. It's got a +3 with it. That means I'm going to do inverse operations of +3, which would be to subtract 3. That goes away. You got y by itself. That's what we're working for. We've got 2x. And then you've got a -8 minus 3. That's going to give you a -11. There is your slope-intercept form. Great job, Coach Sapp. Well, thank you, guys. You are so smart. Y'all are so sweet. All right? So there's your slope-intercept form. So again, we can go point-slope form. The reason we have to use point-slope form as opposed to slope-intercept form is because we don't have the intercept. We just have a given point. We just have a given point. All right. Now, let's go on in your notes. Okay, some of these other ones are just practice problems. Like looking at example number 3, okay, now, we're giving 2 points, which again, we talked about this yesterday. We're given 2 points, but guess what? I can find the slope from 2 points. Your slope formula is y2 minus y1 over x2 minus x1. So then once I have my slope, we'll obviously have a given point. I've got 2 of them. I can choose which one of them. It doesn't matter. And then I can write it in point-slope form. So let's look at example number 3. It says write the equation of a line that passes through the points -1, 4 and 5, 8. So your first step is to find the slope. Because you don't have the slope, so I can find it. But again, rise over run, change in y over change in x. So you've got y2, you've got y1. Okay, well the first thing you need to do is you need to label your point. So this would be x1, y1, that would be point 1. And this would be point 2, so this would be x2, y2. So now let's plug into our formula. y2, which y2 in this case is 8, minus y1, which in this case is 4, over x2, 5, minus x1, which is a -1. So on the top you've got 8 minus 4. 8 minus 4 is a positive 4. On the bottom you got 5 plus 1. You can change, and you get 6. 4 6 is able to reduce. We can divide by 2 on both, and we reduce to 2/3. So what have we just found? We just found what the slope is. Well, guess what, guys? Now we can substitute into point-slope form. Again, point-slope form is y minus y1 is equal to m times x minus x1. Again, why am I not using slope-intercept form? Because neither one of these are your y-intercepts. So let's plug into point-slope form, and then we'll convert to slope-intercept form. So here we go. I know what m is, and I know what a given point is. I can choose either one of these two. I'm going to choose this one because there's no negatives. But it don't matter. You do you, boo-boo. Alright, so here we go. Y minus y1. Y minus, in this case, y1 is the y value of your point, which would be 8. So y minus 8 is equal to m, which is 2/3, x minus x1, which is 5. Okay, now here we go. Again, the way I solve and convert this to slope-intercept form is I'm going to distribute my 2/3. So I've got y minus 8 is equal to 2/3 times x, which is 2/3 x, minus 10/3. How'd you get that, Coach Sapp? Well, I take 2/3 and I'm multiplying by 5 over 1. So in this case, I've got 2 times 5, which gives you 10. On the bottom, I've got 3 times 1, which gives me 3. Okay, now you got one more step. Your last step is I need to move this minus 8, so I'm going to add 8 to both sides. That goes away. You get y is equal to 2/3 x. And then you've got a negative 10/3, and you're going to add 8, which 8 over 1, if I want to get a common denominator, I need to multiply that by 3 on both. So I get 24 over 3. So you've got a 24 over 3, which, again, that's 8. 24 divided by 3 is 8. And you're subtracting 10/3. Okay, so this is 24 over 3. All I did was rewrite this in front to make it easier to see. So now you're subtracting fractions, so you've got 24 minus 10. That's going to give me 14 on top. That's a positive. And then you've got 3 on the bottom. So you've got positive 14/3. Alright, now let's go on to some special cases. So thinking back to our special cases with linear functions, you have a couple meaning 2 special cases, right? We have horizontal lines, and we have vertical lines. Horizontal lines look like this, and vertical lines look like this. So we've already talked about the slope of a horizontal line and the slope of a vertical line. The slope of a horizontal line is going to be 0. Okay? This is O stands for 0. Right? A horizontal line has a 0 slope. Always, always, always. The difference between a horizontal line and a vertical line is that a vertical line has an undefined slope. Again, you cannot walk on that. I can walk on this. There is no slope. There is no rising. Okay, so it's 0. But I cannot walk on this. That's undefined. You'll fall off and you will die. Alright, so I've got a horizontal line. It's got a 0 slope. Guess what, guys? It's going to have a y-intercept. Always, always, always. Because every horizontal line's got to cross that y-axis. Same thing here. This is going to have an x-intercept because every vertical line has to cross the x-axis. Alright, so let's go to letter choice A. Write the equation of the line with the given information in slope-intercept form. So I've got that the slope is 0, so I'm going to plug into y equals mx plus b because, again, slope-intercept form is y equals mx plus b. I know that the slope, m, is 0. That's going to go in place right there. And I know that I have, since I have a 0 slope, I have the y-intercept. You have the y-intercept. Let's plot 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4. Right there. I know I have a horizontal line. Why do I have a horizontal line? Because it's got a 0 slope. So I know my y-intercept has to be the y value of my point. Well, the y value of my point is right here at 4. So the y-intercept, guess what, guys, is at the point 0, 4. Alright, so here we go. Let's plug it in. Y is equal to slope 0, 0x. And then again, your y-intercept is 4. How did I get that? I know I've got a horizontal line because it's got a 0 slope. You know you have the point 9, 4. Well, that y value has got to stay the same because it's a horizontal line. So no matter what x value I pick, the y value's got to be 4. I picked here 0, 4. I picked here, this is 9, 4 because that's the point I'm given. I've got a point over here at negative 10, 4. I got a point at negative 104 if I wanted to. It's a horizontal line. All of them have the same y value. So I've got 0x and I've got plus 4. Now, do we have to write 0x? Nah, trick. So y equals 4. Alright, let's go to B. I got an undefined slope. Got an undefined slope. So you know right now that you have a vertical line because vertical lines have undefined slopes. Let's plot this point, negative 3, 5. So I'm going to go over 3. I'm going to go up 5. There's your point. Alright, now it's a vertical line, so you know that you have a line that looks like this right here. So no matter what y value you pick, your x value is now going to stay the same. Your x value has to be negative 3. Because again, this is a vertical line, so your x value is not changing. You're still on this line right here. But now I can go up whatever I want to, or I can go down whatever I want to. The x value is still negative 3. So the x value, I said x, right? The x value is negative 3. There's your equation of that line. That is 100% different than y equals 4, guys. When I've got a 0 slope, I'm going to get y equals a number. When you've got an undefined slope, you're going to get x equals a number. X equals a number. Alright, again, let me say that again. When you've got y equals a number, you know you've got a horizontal line. When you've got x equals a number, you know you've got a vertical line. That's it, peeps.